Okay, now calculus, we are going to rotate a function around the y-axis. So here is our function, 4 minus x squared. It's a part of an upside down parabola. We're only going to take the part in the quadrant 1 right here. So this is our graph. Here is our region in quadrant 1. Because our rectangle has to be perpendicular to the axis of rotation, we're going to put in a rectangle that is horizontal. Okay, so the rule for volume is you put a rectangle in the region that is perpendicular to the axis of rotation. All right? So if we are rotating it around the y-axis, our rectangle is horizontal. Okay, now that is a horizontal length. All right, so that is a x value. All right, so the radius is an x value. All right, now when we spin this region around the y-axis, we get a three-dimensional paraboloid right here. This rectangle becomes the radius of the disk. And the radius of the disk is x. There you go. So to set up our definite integral, we need the elongated s. Again, we need area of the base times the height. We need area of a circle because the shape of the base is a circle. And the area of a circle is pi r squared. And we know that our radius in this problem, when we rotate around the y-axis, we replace it with x, pi x squared. Now for the height, again, the height is the thickness of that disk. All right, that is the height. All right, because it is a vertical length, that is a difference in y. All right, so the height is a difference in y. We represent that with the symbol dy. So we pop that in right here. All right, so the height is a dy. All right, so area of the circle, pi r squared becomes pi x squared. Our height is dy. Now remember to plug in x. All right, so the pi comes along. We plug in x right here. All right, and we know that our equation, let's go see. Our equation is solved for y. So whenever you're rotating about the y-axis, we have to solve our equations for x. So let's take our equation, y is equal to 4 minus x squared, and let's solve that for x. The first thing that we're going to do is we're going to subtract 4 from both sides. So we get y minus 4 on the left. On the right, we have negative x squared. Before we can take the square root, we have to get rid of a negative. So we're just going to multiply through by a negative. So I'm going to go up here. So instead of y minus 4, I'm going to multiply through by a negative, and I get negative y plus 4 is equal to positive x squared, and now I can take the square root. So the square root of x squared is x, and I'm just going to leave that as the square root of negative y plus 4. All right, so my x is equal to negative y plus 4. So now I can plug that in right here. My x is equal to the square root of negative y plus 4. And that's why you want to leave the square root in, because when you plug it in, that square root and this squared will cancel each other out. So now when we simplify it, we can do this. We just have pi, parentheses, negative y plus 4. Again, the square and the square root cancel each other out, and we are left with what's inside, negative y plus 4. Now we need to find the limits for our definite integral. We need a and b, so we're going to go up to the graph. Remember, the limits are along the axis of rotation. Okay, so if we're rotating about the y-axis, our limits are going to be from low to high. All right, so the lowest value in our region is 0. All right, and we go all the way up to this y value right here, and that y value is 4. This parabola crosses the y-axis at 4. So our limits are from 0 to 4. So there is our definite integral, and that was our goal right here. All right, so we solved that using the fundamental theorem of calculus. So our antiderivative, pi comes along for the ride and it gets distributed. These are two power rules. So the antiderivative of negative y is going to be negative y squared over 2. So negative 1/2 y squared. And the antiderivative of 4 is 4y. Make sure that you put parentheses around that so the pi gets distributed. And then, of course, we use a bracket to bring along our limits of integration. All right, second step, fundamental theorem of calculus. We plug 4 into the antiderivative, and then we plug in 0 into the antiderivative. It's always upper minus lower. All right, so I would put your equation incorrectly with the parentheses into y equals and use your calculator table. When I plug in 4, I get 25.13, and when you plug in 0, you get 0. So our volume is 25.13 units cubed. Okay, so let's review everything we need to remember about rotating it along the y-axis. The first thing we want to remember is that you have to put in a horizontal rectangle in your region, okay? So it is a radius of x. So let's put in our rectangle right here. This is radius, and it's an x value, all right? And the thickness of that is, of course, a vertical length. So that is a vertical length. That is our height. So the height will always be a dx. All right. The limits, a and b, are along the axis of rotation, so they are along the y-axis. All right, so they are from low to high. All right, so those are my limits. And finally, your definite integral will have y's in it, all right? It will be y's and dy. All right, that is a rotation along the y-axis. So head over to the homework worksheet, and there will be a video that goes through each of those problems. Thanks, calculus.